Hi guys, this is the 10-Minute Tutor, and in today's video we're going to be talking about forces in physics. We're going to be answering the questions such as what do forces mean, why are they important, and what are the different types of forces. The purpose of this video is to be a very simple explanation of the different types of forces without going into too much detail about the mathematics behind them. It's just a brief overview so people can better understand them. So pretend we have a person here. This is going to be person A. And he's pushing person B, who has a weird shaped head. He's pushing him this direction. This would be one of the basic explanation of a force, because like we said in physics, a force can be a push or pull on an object, and this would be person A pushing person B a specific direction. As you can see, the force is directional, they're going a certain direction. So that's just a very basic explanation. Now mathematically, the unit force is represented by an F. And it's in units of newtons, or Newton, as a capital N. So that's how we would show it mathematically. And 1 Newton, just for anybody who's curious, 1 Newton is the force required to accelerate 1 gram of mass by 1 centimeter per second squared. And although, the example of a force can just be somebody pushing somebody else, they can be a lot more complicated, as we see here. Remember placing 2 magnets together. If you have the same poles, the magnet will repel. They will repel each other because there's going to be an electromagnetic force going in opposite directions. That's why if you put together 2 negative poles of 2 different magnets, you'll feel them pushing apart. That's also an example of a type of force. So from Newton's second law of motion, the equation for force is F equals ma. So this is a very important equation. It's one of the most basic ones that you're going to be learning in physics. In the equation F equals ma, the F is going to stand for force, like we talked about, is measured in newtons. The M is going to stand for mass, which is usually in grams. And the A is going to be the acceleration, which can vary depending on what you're talking about. So on Earth, it's 9.8 meters per second squared. If you're giving just an equation about something free-falling, the acceleration would be 9.8 meters per second squared. But it varies, like we said, depending on what we're talking about. Okay, so going back to our previous lessons about vectors, you would understand that a force is actually a vector quality. So what are the 2 things that make up vectors? So in order to be a vector, it must have a magnitude and also a direction. Without these 2 components, it cannot be a vector. So just exactly how does a force have a magnitude and a direction? Well, take for example, imagine that you have a rock. Here's a cliff, and you have a rock that just fell off a cliff, and it's heading this direction. The force of this direction would be mg or w, where weight is equivalent to mass times gravity, because that is the force that is going to be bringing the rock down. If you're on Earth, it's going to be the force of gravity. And this represents the magnitude component. And just for argument's sake, say that the rock is heading southward, because it's falling down, it's going in a southward direction. This would be represented as the direction, because we're talking about the specific direction that the rock is going based on the force. So in this example, we can clearly see that force is a vector, because it has both a direction and a magnitude. If you guys are confused on what a vector is, you should check out our video on vectors. It's a very simple explanation that really talks about vectors conceptually and helps you guys understand it much easier. So it's in the playlist if you guys are curious. Now, sometimes you have to understand that the force, there can be many different types of forces. You don't always have one force that is acting on an object. Sometimes there are multiple forces acting in a way of equilibrium. So take, for example, you have somebody here. They're standing on the floor. So somebody is standing on the floor right here. Well, the forces that are acting are their weight. So the weight, W equals mg, is pulling them towards the floor. But at the same time, there's also something called the normal force, which is represented as Fn, or normal force. So the normal force is actually the floor pushing up at you. And in this example, the force of the floor pushing at the person is equal to the force of the person pushing down at the floor. So in this case, mg is actually equivalent to Fn, and we're in a state of equilibrium because there's no movement. The person is standing still because the normal force is equivalent to the weight of the person, or the mg. Okay, so the first type of force that we're going to be talking about is the force of friction. So there's a force of friction, which is usually represented as Fk. So we know friction, or the force of friction, is the force when one object rubs against another. So, for example, imagine we have a box here, and it's on a pretty rough surface. So not a very nice smooth surface. And there's an applied force going in this direction, represented as Fa, which is going to be the applied force. But at the same time, going in the opposite direction, in lesser of a magnitude, there's going to be an Fk, which is the force of friction. And this force is actually slowing down the box just a little bit because of the friction that is going in the opposite direction. And another type of force that we're going to be talking about is the gravity force. So this is a force caused by a large body such as the Earth. So we know that somebody who is standing on Earth, like all of us, there's a force that is acting downwards at us at 9.8 meters per second squared. This is going to be the force of gravity heading downwards, which is going to be equivalent to g, or lowercase g for gravity. So another type of force that we're going to talk about is the electromagnetic force, which we kind of talked about a little bit before. So electromagnetic force is essentially a force associated with electric fields. So like we said before, when you have two magnets coming together with the same poles coming together, there's going to be a force going in the opposite direction. It's going to be the electric force. Or if you have the same magnets, you have the opposite direction, these magnets will actually be attracting each other if you have opposite poles, because we know opposite poles attract. So in this case, they would actually attract, but over here, they would repel. When we're talking about the next force, this is going to be the nuclear force. So the nuclear force is actually a very strong force that holds together atoms and particles. So we're talking about, we know a nucleus is made up of protons and neutrons. So we have a whole bunch of protons inside a nucleus, and then I'm just going to draw neutrons as slashes. We have a whole bunch of neutrons. So inside this nucleus, there's actually a very strong force that's holding together the protons and neutrons. And this is actually going to be represented as the nuclear force. There's actually a nuclear force that's holding together the protons and neutrons inside the atom. Another force that you're going to see encountered a lot in physics is actually the tension force. So this is a force exerted by some sort of rope, cable, or chain. So usually a rope or cable. So you're going to see a lot of examples like, pretend this is the ceiling and there's just something hanging off the ceiling. Well, actually, this is a cable here. And there's going to be a force of tension, or an Ft, acting on the object upwards, because the object's weight is heading southwards, or it's going to be heading downwards, but there's also a force of tension heading the opposite direction. So that's another type of force. And finally, we're going to be talking about an elastic force. So an elastic force is a force of an object trying to retain its natural length. So this is essentially the force that a spring exerts when it's trying to return to its normal length. So pretend you have a string here that's stretched. There's actually going to be a force of the spring, or the elastic force Fe, of the force of the spring trying to retain its natural look like this. So there's going to be a force of it heading in a certain direction, so it tries to come to its natural length. And this is going to be the normal. So there you have it. Those are the 6 types of forces. If you guys are interested in any other types of videos like this, we'll definitely be making more.